Hello, my name is Joseph Ekes.
I'm Andrew Wirball.
I'm Leonardo Ruiz.
I'm Lowe. We are Group 9 for the Spring 2025 Iowa State IMSE capstone class. We worked on our project at Pella Corporation in Pella, Iowa. We focused our project on working on their vertical metal paint line and preventing parts from falling off of it. For the problem overview, the purpose statement of this project was to eliminate lineal pieces from detaching from the chain. The vertical metal paint line has lineal parts that are getting detached from the hangers and falling, which are causing damage to all the remaining parts on the chain that are coming in contact with that fallen part. As you can see, Pella's average annual loss is $530,000, which is a very substantial amount. Now we're going to do an overview of the process real quick. So the parts start in the loading area where they're loaded, then they go through a chemical pre-treat, then they dry, then they go into priming and painting silos where they're primed and painted, then they go through a big curing oven, and then they're unloaded at the end by the operators.
On the left is a brand new hook that Pella would use, and on the right is a hook at the end of its production cycle. Noticeable differences are the paint buildup and the dullness of the biting part.
Here's a clip of a Pella operator loading parts onto the line.
Talk about the current state. We completed many Gemba walks throughout the semester, mainly in pre-treat and the oven, as well as operator interviews. We also made a process layout diagram for the team and for Pella to organize the line into areas. We completed a time study to determine the entire runtime of the line and determine where parts spent the most time in these specific areas. We completed a root cause analysis to determine reasonings for parts falling in 3 main areas. We put together a scrap part data collection sheet to figure out how many parts are falling in each area that we looked at, as well as created a total preventative maintenance survey for the maintenance team to get their opinions on where parts are falling and what are the most important parts to look at. We completed a finite element analysis on the hooks to look for deformations based on the heat of the oven, as well as completed hooking effectiveness experiments to see at what weight the parts fell at and the angle that they fell at. We looked at 2 hooks, one ideal hook that was brand new and one that was paint covered and had deformations.
Future state recommendations. First, the team aims to reduce movement of parts by doing the following: addressing overall line maintenance to eliminate any shakiness of the line, lowering impingement and excessive force on parts during pre-treat from a jet stream flow pattern nozzle that's seen in the bottom left to a mist stream flow pattern that is the green nozzle on the right, and to finally rework the oven vent orientation to make sure ducts are aligned properly to ensure proper airflow in the oven. Next is to improve the hooking effectiveness. The team recommends to use 316 stainless steel instead of the current 304 stainless steel to delay any physical deformation that may be occurring as seen in the bottom of your screen, to develop a quality inspection procedure for paint burn-offs so the hooks are not as covered in paint near the end of their life, and to finally implement better PPE for hooking operators to ensure that less hand fatigue is experienced and proper placement of hooks are put on the profiles of parts. And finally, a detection solution the team recommends is to implement a motion camera via Belco to eliminate spider webbing in the oven. As seen in the bottom of the screen is a process layout diagram of where an andon system and TV monitors will be located to help ensure operators know when a part has fallen and to alert management of any spider webbing.
Finally, we will discuss the economic impact that this project will have on Pella. So, below in this table, we have the net cash flow savings, combining the detection solutions and the prevention solution costs over the next 3 years. Calculating also a 95% scrap part savings due to these implementations, Pella will be saving around $500,000 per year and have a net present value savings of around $1.3 million. Another project impact is that the reduction in spider webbing means that Pella will have a reduction in part batches that need to be rerun. This means that scheduling for the day will be more consistent and a higher probability that orders scheduled that day will go out on time. Thanks for watching.